Let us explore the results of an Euler buckling analysis. Let's find the calculator, Euler buckling, and we find ourselves here. Today we're going to look at the results from an example from Collins from this book, the first reference, and it's on page 88. So let us start the configuration. We're going to go and find the critical force for a member that is fixed free. The length of it that is specified is in feet, and it's 9 feet, and the cross-sectional area is going to be a circular tube with a 4-inch OD. And we're going to change that to inches, and at the same time we're going to change that to inches. 4-inch OD, and it calls for a wall thickness of 1/8, but we're just going to say ID is 3.75. The material is an aluminum alloy, and for the material, what we have here is the Young's modulus, but it's given in English units, so we're going to change that. 10,500. I can make that as a KSI, but I'm just going to 1, 2, 3 more. And let's run the analysis. And let's see what we have here. We're going to compare a couple of values. So the first one that we're going to compare is the P critical force. The example says 6,350 pounds. So critical buckling force, we're going to change this to pounds, and let's see what we have. I get 6,351 versus 6,350. So that's correct. The next one is going to be the radius of gyration. I get 34.817 millimeters, but the answer in the book is given in inches. So let's convert that to inches. It's 1.37 in the book. We're calculating 1.371 inches. So that's correct. And now critical buckling stress. This is given now. Let's change it to PSI. And the book calls for this example problem 4170, and we are measuring here 4173. Now, one of the things that happens automatically is the cross-sectional area. As you change the geometry, it will actually update this equation accordingly. This is the radius of gyration, and just remember that the I, area moment of inertia, that comes in here is actually the minimum area moment of inertia. Area moment of inertia, the tangential slender ratio, and if you want to learn more about this, you can go to Lindenberg, which is one of the references on top. The slender ratio, which is the effective length, which is the coefficient times the actual physical length, divided by the radius of gyration, the critical force, which most people are familiar with, and the critical buckling stress. For those who subscribe to our universe plan, you'll be able to click on PDF report, and you'll be able to get a configuration of the analysis that's being done. This QR code will take you directly to the calculator, and on the next page you'll get a summary of the results. If you like this video, subscribe and give us a thumbs up. Until next time.